Okay, so today we're going to work on 1.2, complex numbers. So our objective here is to simplify square roots of negative numbers and simplify complex numbers. So we're going to take a look here. So this definition is important here. It's important to realize that the square root of -1 is considered to be I when we solve. So in that regard, I squared is equal to -1. So again, here's some step-by-step instructions, but I'm going to model these for you so you can read those for yourself. So in this case here, I know that the square root of 9 is 3, and because of the negative there, I get -1. I get an I to help with the negative. On this next one, 45 is not a perfect square. So over here, I'm going to come and do what I call a factor tree to help me do the prime factorization. So if I do the prime factorization of 45, 45 is divisible by 5. 5 goes into 45 9 times. And then 9 is divisible by 3. So my prime factorization of 45 is 5 times 3 times 3. Since I'm doing squared here, I have to have a pair to pull it to the front. So if I do the square here, I'm going to have 3 square root, and then that 5 is left on the inside, and I don't want to lose that negative that I have there. So to get rid of the negative, then I pull an I to the front. So my solution is 3I square root 5. For 96, we can also do a factor tree. 96 is divisible by 3, so we get 3 and 2 here. So then 32 is divisible by 2. We get 2 and 16, 2 and 8, 2 and 4, 2 and 2. So I'm running out of room, so I'm going to write my prime factorization actually inside here. So I have 1, 2, 3, 4, 5 2's. 5 2's and a 3. So again, pairs have to come out. So I have a pair of 2's here, a pair of 2's here. So when a pair comes out, we just see them as 1. So I have -2 times 2 coming out, left in with -2 times 3. So this is going to give me a -4. And a -6. Now I still need to take care of that negative on the inside there. So I'm going to pull that out with an I. So I get -4I square root 6. And so again, 48 is also not a perfect square. So I'm going to divide by 4. 4 is not prime, so that can factor to 2 and 2. But when I divide 48 by 4, I get 2 and 4. So that's divisible by 3 and 8. And so then that can be 2 and 4 and 2 and 2. So I'm going to work this one the same way. That's the square root of negative. We have 1, 2, 3, 4, 5 2's. And we have a 3. Oh, I did some wonky things right there, right? 3 times 8. No, that's right. 3 times 8 is 24. Oh, instead of dividing 48, Lord, guys. Okay, let's try again. So 48 divided by 4 would give me 12, right? because 4 goes into 4 once and 4 goes into 8 twice. There we go. That makes more sense. So then we divide by 2, get 6, divide by 2, and get 3. So in this case, we have 1, 2, 3, 4 2s and 1 3. So we can pull pairs out. So again, when we pull the pairs out, they move to, we consider them 1 now because we're taking the square root. And I can go ahead and pull that negative by making it an I, and I'm just left with a 3 on the inside. So I get 4i square root of 3 as my final answer there. So complex numbers have what's called a real part and an imaginary part. So the real part is the numerical part, and the imaginary part is the part that contains the I. So in this case, if we have 2 plus 3i, the real part of the number is 2, and the imaginary part of the number is the 3i here. So these are other examples of complex numbers. 7 would be our real part. Negative I would be our imaginary part. And then here, you might think, well, this is just an imaginary number, but every imaginary number can be written as a real number, a complex number, because the real portion is just 0 here. So we have a real portion of 0, and the imaginary portion is negative 5i. So if we take a look here, this is all about taking care of that negative on the inside and then simplifying as well as we can. So we know the square root of 36 is 6. So we would get 4 plus 6i over 8 to take care of the negative. And then we want to reduce if we can. When we reduce, we're just looking at the numerical parts. So this 4, 8, and 6 are all divisible by 2. So if I divide all of those by 2, I get a 2 here, a 3 here, and a 4 here. So now I get 2 plus 3i over 4. Well, I can break this up into 2 over 4 plus 3 over 4i, so that it's more clear that it's a complex number. We have our real part as 2/4 and our imaginary part as 3/4 I. When we do that, we can see here that 2/4 also can reduce, right? That reduces to 1/2. So my final answer would be 1/2 plus 3/4 I. On this next one here, 18 is not a perfect square, so we can do our factor tree. And we have a pair of 3's to pull out to the front, so we get 5 minus 3i square root of 2, because we have that 2 left over. And that's all over 12. So I can break this up as 5 over 12 minus 3 over 3 square root of 2, actually, over 12i. So my 3 and my 12 can cancel, or reduce, actually. The 3 becomes a 1, and the 12 becomes a 4. So to make things clear here, because it can kind of get jumbled to see what's going on here, I'm going to write this as 5/12 minus 1 over 4 I square root of 2. I write it that way so that I don't get confused and think that the I is inside of that square root there. All right, so that concluded 1.2. The next time we're together, we will work on 1.3.